Hello, this is Mr. Collier, and today we're doing some probabilities with some single and combined events. Okay, so we have, here's just a number line of all the different probabilities, or possible probabilities. Okay, the probability has to be between 0 and 1, between 0% and 100%, obviously. Alright, so you can write probabilities as a decimal, fraction, or a percent. And theoretical probability is the probability of an event is the number of successful ways an event can happen over the total number of possibilities, and we'll see what that means in a bit. In a deck of cards, give the probability of each event. So a deck of cards has the ranks ace, 2, 3, all the way up to 10, and then jack, queen, king, and each of those has a suit. It could be hearts, clubs, that looks like a club, diamond, and spades. Okay, so they have 4 suits, and there's 13 cards, so it's 52 altogether in a deck of cards, not including the jokers. So in a deck of cards, give the probability that you randomly, like you pick one card, you get a 7 of spades. Well, there's only one 7 of spades, so the number of ways that can happen is 1, and the total number of possibilities is 52. Okay, so the probability is 52. That's about almost 2% if you write that as a percent. The probability of a club. Well, there's 4 suits. Okay, so there's a 1 in 4 chance you will get a club. You could also write that as 13 out of 52, which simplifies to a quarter. There's 13 clubs in a deck. A non-face card. Well, face card is these cards here because they actually have pictures of a face on there. So there are 12 of those, right? There's 4 of each, so there's 12 face cards. So that means there's 40 non-face cards. So it's 40 out of 52, which we can simplify. That's 20 out of 26, and that's 10 out of 13 is the problem. Well, okay, we could have done that straight away, right? Just there's 10 non-face cards here out of a total of 13 of the ranks. What's the probability of a queen? There's 4 queens in the whole deck, so it's 4 out of 52, or just 1 out of 13. Face card, there's 3 in the rank of 13, so that's 3 out of 13. And not a queen, well, this is a queen, so not a queen is just 1 minus this answer, which is 12 out of 13, right? The queen and not a queen have to add together to give you 1. Okay, so let's take a look at this one. A complementary event. So the probability of an event not occurring is equal to 1 minus the probability of an event occurring, which is kind of common sense, but sometimes it's easier to calculate this than it is to calculate this, so it's an important thing to remember. Also, experimental probability. Sometimes you can't really figure out the theoretical probability, so you have to do an experiment. So the experimental probability is the frequency over number of trials. For example, you want to get the probability of somebody scoring a basket in basketball, you have to look at the total number of baskets they got divided by the total number of shots they take, and then you get a shot percentage. Okay, so here we're going to do some experimental probability. That means actually rolling some dice, and theoretical probability as well. So I'm going to write the theoretical probabilities first, then we'll talk about how to get the experimental probability. Okay, so probability of getting a 4. Well, there's 6 6-sided die, so we have 1, 2, 3, 4, 5, and 6 different possibilities. Probability of getting 4 is just 1 out of 6 then. Okay, and probably an odd number. Well, there's 3 of them are odd, so 3 out of 6 or a half is that probability. And for C, divisible by 2 or 3, well, that is, this one is divisible by 2, this one's divisible by 3, this one's divisible by 2, and this one's divisible by 3. So the probability that it's divisible by 2 or 3 is 4 out of 6, or 2/3. Okay, and the probability the number is less than 5, well, there's 4 of those, so it's also 2/3. So if I were to actually roll a die 50 times, and about half the time you get an odd number, so approximately 25. Probably won't be exactly 25, but it'll be close to 25. And the probability of getting a 4 is 25% or a quarter. So about 12.5 times you would get a 4, right? To do this experiment, you can obviously roll a die yourself. I'm going to show you how to do it on your calculator as well. So on the TID4, you can go to Math, go over to Probability here on the top. Random integer is number 5. Then you can type 1, 6, and it'll give you a number between an integer between 1 and 6. So it's just like a dice roll. On HP Prime, you can click on the toolbox here, and you go to Probability. Random is number 4, integer is number 2, and then again you just do 1, 6, and you get integers between 1 and 6. Okay, next we're going to look at sample space, and that's when you basically write out all the possibilities so you can figure out the probabilities. Okay, so the sample space of tossing one coin is just heads or tails. There's only 2 possibilities. Rolling a 6-sided die, then the possibilities are 1 through 6, so it's just writing out all the possibilities. So let's do this for this one here. Twirling a spinner, so spinner would look like something like this: A, B, C, D, with arrow here that you can spin around, then it randomly lands on A, B, C, or D. So the sample space is A, B, C, D. And the sexes of a 2-child family. So it's 2 children, so you could have boy, 2 boys, or you could have boy, girl, or girl, boy, or girl, girl. Okay, so these are the 4 different possibilities. There's 4 possibilities in the sample space. Okay, so the order does matter. These are the same. Basically the same thing. It was 1 boy and 1 girl, but this is the first one's a boy and the second one's a girl. The first one's a girl and the second one's a boy. So you need both of them listed in the sample space to be able to work out the probabilities. The order in which 4 blocks can be lined up. So the order does matter. So you can have, this one's going to be a bit longer, I believe. The order matters, so you can have A, B, C, D. You can have A, B, D, C. You could have A, now I've done that, so I could have A, C, B, D, A, C, D, B. Or I could have an A and a D and a B, C, A, D, C, B. Now that's all the possibilities starting with A. Now you can do the same thing starting with B and write 6 different possibilities. Do the same thing starting with C and write 6 different possibilities, and then with D as well, and you get 6 possibilities for each one. So the total of the sample space is actually 24 if you write them all out. Okay, here's sometimes you make a little grid, especially good for multiple coin flips or rolls of a die or something like that. Okay, so if you flip a coin twice, you have 4 possibilities, right? And you could also represent this with a diagram. Like this represents coin 1, so the first coin was tails and the second one was heads, right? So there's 4 possibilities here. Just another way to write this here. Okay, this is an important one to know. the possible outcomes when rolling dice. So if you roll 2 dice, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you can obviously get 1 through 6 on the first die and 1 through 6 on the second one. So the possible outcomes are 1, 1, 1. Let's call that 2, 1. 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. Okay, so now that we got all the possibilities written out, we can actually work out some probabilities. So a sum of 6, that would be, well, 1, 5 is a sum of 6. 2, 4, 3, 3, 4, 2, and 5, 1. So it's actually 5 possibilities out of actually a total of 36. Okay, so notice, like, if you were to do a sum of 1 or sum of 2, there's only one possibility, so the sum of 2 would be actually just 1 out of 36. So there's a big difference. This is 5 times as big, right? And the one with the most number of possibilities is 7, right? This whole row, it represents a sum of 7. That's why they call it lucky number 7. It's the most common outcome when you're rolling 2 dice, and then the next likely outcome is a sum of 6, 5, 4, 3, and 2 is the lowest, and 12 is the lowest on this end, right? So 7 is the most likely outcome when rolling 2 dice. It's 6 out of 36, which is a 1/6 chance, which is about 17%. Okay, a sum greater than 8. Let's look at where it's equal to 8. And I'm going to use purple here. So here it's equal to 8, right? All these are equal to 8, and these numbers here are bigger than 8. So this whole section here is all the possibilities where the sum is greater than 8. Okay, so that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 out of 36, which is kind of close to 50%. It's almost half. Okay, next we have a bag contains 5 red balls, 3 green balls, a ball selected at random, and the second ball selected at random. Draw a tree diagram to show that probability. Okay. And not replaced. Okay, that's an important feature right there. Okay, so I'll draw that tree diagram. So you get 2 possibilities. You can draw a red or a green ball for your first pick, and second pick also is either red or green. Okay, the probability of getting red is 5 out of 8 here, and green is 3 out of 8. Now this is a very important thing, because if they are replaced, then the probability stay the same. It will be 5 over 8, 3 out of 8, 5 over 8, 3 out of 8. It will be the same, but since it's not replaced, then this is the case where one of the red marbles or one of the red balls is gone. So now there's not 5 red balls anymore, there's 4. So this is actually 4 out of 8, which is half if you like. And, sorry, it's not 4 out of 8. That's not right. Because there's 4 red balls, but there's also going to be 7 in total, because one of those 8 is gone. So it's 4 out of 7 and 3 out of 7 are the probabilities. And this scenario, one of the green ones is gone, so now there's 2 green, and a total of 7, and this one's 5 out of 7. Okay, so from this we can work out 4 different probabilities. We can work out the probability of red. That means getting a red, picking a red ball and then another red ball. We can get the probability of red, green, green, red, green, green. So we can get those 4 probabilities. So probably 1 red and 1 green, that's the probability of red, green, plus the probability of green, red. So we're going to add those 2 probabilities together. So red, green is this branch right here. We get red is 5/8, green is 5/7. So it's actually 5/8 times 3/7, plus 3/8 times 5/7. Okay, so we worked it out. That's 15 out of 56 plus 15 out of 56, which equals 30 out of 56. If I simplify that, that's 15 out of 28. Right? Okay, next we're going to look at a Venn diagram. In a class of 40 students, 10 play tennis, 20 play netball, and 5 play neither of these sports. A student is randomly selected from the class. Draw a Venn diagram to represent this information. So it's tennis, netball. There's 2 sports. So a Venn diagram is going to have 2 circles because there's 2 sports. If there's 3, we'd have another one here. So tennis, netball, there's 40 students. 8 play neither, so we can stick that in here. Now, 19 play tennis and 20 play netball. So if I did 19 and 20 here, notice now these numbers add up to bigger than 40, right? So this isn't quite right. 19 play tennis and 20 play netball. Some of them play both, right? So if we add these 2 numbers together, we get 39. But what we want in these 2 circles is we want 32, because there's 8 out here. It has to be 32 in these 2 circles. Okay, it has to be 32, so that means there's 7. We have 7 too many, so there's 7 in the intersection. And I'll take away 7 from both of these. So this is 13. Oops. That's 13, and take away 7 from that, you get 12. So this is what the Venn diagram should look like, and these numbers do add up to 40. So now down here, find the probability that a randomly selected student plays tennis. So the probability of a student playing tennis is, well, there's 19 tennis players out of 40, so it's simply that. Does not play netball. Well, 20 play netball, so 20 do not play netball. So we can write this as like this. So it's 20 out of 40, which is just half, or 50%. Plays at least 1 sport. That's the same as 1 minus the probability of no sports. Okay, so that is 1 minus 8 out of 40 is the probability of no sports. So that is 32 out of 40, which you could divide by, let's divide by 4, and then we get 8 out of 10, so that's 80% if you like. Plays tennis knowing he or she plays netball. So this is actually something called conditional probability that we're going to do later. This is important, knowing that he plays netball. If you know that somebody plays netball, then you just look at the netball section. Okay, it's one of these 20 people. Okay, so if we know they play netball, there's only 20 possibilities. So the probability that this person plays tennis is actually 7 out of 20. Okay, we'll do more of those probabilities later.